This is a write-up for the Provably Secure 2 challenge of the DiceCTF 2023. For the challenge, we are given a server.py. Looks like the following. The server will give you 128 experiments, and in every experiment you have to guess some bit. Now I've converted this to pseudocode to make it more readable, so let's take a look at that. The pseudocode shows that the server generates two key pairs, and it generates a random bit and an array of seen ciphertext. It then gives you 8 turns, and you can make a choice. If you choose to guess, you either have to guess the bit right or the program quits. If you choose to encrypt, you have to send it 2 messages, and based on the bit, it will choose one of the messages and encrypt it, and return to you the ciphertext. Then you have a third option, which is to decrypt a message. However, you cannot give it the ciphertext that you were given, because it will be in the seen array. You see here, it adds it to the seen array. So you cannot just encrypt the value and then give it back and then get the decrypted message. So let's now look at how the decryption works. Over here we have the encryption and decryption. The encrypt function takes the message and XORs it with a random value. It then generates 2 parts. The left part will just be an encrypted random value with the first key pair, and the right part will be an encrypted value of your message XORed with that random value with the second key pair. And it will also include some kind of integrity thing. Then for decryption, it just splits the 2 parts, and it will decrypt the left part and the right part. The left part just being the random value again, the right part being the message with XORed with the random value. So the XORed is together, and you get back the message. Now, what's important to note is that it does some integrity checking, so something that has been encrypted with the first key pair can only be decrypted with the first key pair, or this thing will start to complain. All right, now let's look at how we can crack this schema. So just real quick, let's connect to the server. It will allow you to encrypt something. We'll give it 16 bytes, give it 16 different bytes. It will give you back some ciphertext. You can choose to decrypt the ciphertext, but it won't allow you. You have to give it some other ciphertext. Oh, it doesn't allow that. But so again, you can also try to guess a bit, and if you guess it wrong, the program quits. All right, now we're gonna take a look at the cryptographic schema. So here I highlighted in red the things that we don't know. Although the server returns the public keys to us, I solved it without having to use these public keys. So if you encrypt the message, it will generate a random value. I call this R1 for the first message, because again, every encryption generates a new random value. And so if you have another message, it will be XORed with another random value. So if you decrypt those, it looks like this. Now what we can do is we can actually mangle these blocks around. So again, something that's encrypted with the first key has to be decrypted with first key. So what we can do is we can take the first block of the first message and the second block of the second message, so these two, and then we can send it to the server. Now what happens if we do that? It will decrypt those blocks, and we get back, well, 2 random values XORed with one of our messages, which is of course useless. Because again, remember, it chooses one of the messages that we sent. We have to send it 2 messages, and we don't know which one it picked. So this is gibberish. However, there's a way to break this, and maybe you can already see it. If you cannot see it, maybe try pausing the video and looking at this for a while before we go to the next part, which is cracking this crypto schema. All right, here we go. Again, we can do this, But we can also do this. We can also take the second message first part and the first message second part. And now what happens? So we've seen this before. If we just do the first mangling, let's say, we get R1 XORed with R2 XORed with some message. But now if we do the second thing, we get R2 XORed with R1 XORed with some other message. And of course, if we XOR those two together, we get just two of our XORed messages back. Now, why is this handy? Let me show you the pwnscript. So here's the pwnscript. We connect to the server and we create 4 messages. And the messages, they differ at the last byte. Right? We have some XOR functions, something to send and receive. We have a function where we say, give me the encrypted value for these 2 messages. And we are able to decrypt some value. So what we're going to do is we're going to send it our first 2 messages. We're going to get the ciphertext. We're going to send it message 3 and 4, and we're going to get the ciphertext. We're going to then switch the blocks around like we've seen before. And we will then get the decrypted values for those switched ciphertext, which it allows because it hasn't seen those before. And then we're going to XOR those 2 decrypted values together, right? And we're going to check if it matches the XOR of our messages. Because if the bit is 1, it will choose message 1 and message 3. But if the bit is, if the bit is 0, it will be M1 and M3. And if the bit is 1, it will be M2 and M4. So I hope that makes sense. So if we run this, we'll actually be able to see that this is indeed the case. So here you see me switching the blocks around. So see, first part of the first ciphertext, second part of the second ciphertext, etc. That allows us to know the bits. So let's have this run for a while. And there we go. There is our flag. So a big thank you to the DiceCTF creators. It was a fun challenge and I hope you enjoyed watching. As always, don't forget to like yourself and I hope to see you next time.